Alright, welcome to lesson 9. We're going to be working on some slightly more complicated situations where we're going to implement a bunch of different rules together, in particular the chain rule and the quotient rule. Alright, here's a problem for you to try. I wouldn't call it a discovery problem since there's really no new concept that you're discovering, but nonetheless it is a slightly more advanced and different type of function. So find the derivative and then press play and we'll talk about it. So in order to take the derivative here, I've got to notice a couple of things. The first is that I need to apply the chain rule to take the sine, the derivative of the sine of this other function, right? So the outside function is sine, it's being applied to this inside function. So I'm going to take the derivative of the outside with respect to this inside function, and then the derivative of the inside function. So f prime of x is going to be the derivative of the outside function. So the derivative of sine is cosine. So it'll be cosine of whatever this is, 4x squared plus 1 over the square root of x times the derivative of the inside function. So the derivative with respect to x of this interior, 4x squared plus 1 over the square root of x. Now at this point, the realization that hits you is that taking the derivative of this piece here, of the inside of g of x, if you will, is going to require the quotient rule. So in order to keep ourselves organized and not lose total track and control of the problem, what it would be ideal is to go off to the side and take the derivative of this piece and then come back knowing what the derivative of this is and insert that now for this piece so that we can then simplify. Instead of applying the quotient rule in the next line here and having to work simultaneously while bringing down my cosine along the way. So I'll show you what that looks like. Alright, so I've taken my work off to the side. One thing to note is you don't want to have this blue flowchart looking thing in your work. As long as you have this off to the side, and I'm just drawing this to show you it's off to the side, as long as you have this off to the side, it can be clearly and quickly referenced by yourself or anyone that's checking the work, and you can always mention it in an explanation if you want. But try and avoid arrows and stuff like that. So we're going to apply the quotient rule, and I encourage you to go ahead and stop and do this on your own, and then come back and quickly check your answer. Alright, here's the solution using the quotient rule. Just a couple things that you might be curious about. X to the 1/2, which is the square root of x, times x to the 1 is going to be x to the 3/2. That's where this comes from. And then square root of x squared, obviously 1 over x. That comes from me bringing this out side. So dividing by something is multiplying by its reciprocal, and square root of x squared is x. And then I just did some simplification. X squared divided by x is going to be x to the 1, and then x to the 1 divided by x to the 1/2 is x to the 1/2. So on and so forth. And that's my simplified answer. And so now I can come back over and continue my work here, finding the derivative of my function f, which is going to be, again, cosine 4x squared plus 1 over the square root of x, then times this piece here, which is 6 square root of x minus 1 over 2x to the 3/2. Okay. And I can leave it in this form. Certainly I could multiply and distribute the cosine in, but notice that that's not really going to help me. That's just going to mean I'd have to evaluate cosine one more time, and that's not actually a more simplified version. You could combine these two expressions here by finding a common denominator, and you certainly can do that if you want, but that's really the only simplification that I might make. And in fact, this is about as simple as it's going to get for this function, and so if I had to find the derivative at a certain x value, I could plug this in to this particular function and compute. So the basic idea here is that we need to make sure we're organized. We need to make sure that you are very clear in what you're doing and have a plan for it before you jump in. So when you see a function and you're taking the derivative, before you do anything, have a fully mapped out plan, at least to a point where you know you're going to be on the right track, so that you can execute it without having to go back and rethink what your process should be. So here I look at the function, I see that it is a composite function. The outside function is the sine of x, and the inside function is 4x squared plus 1 over square root of x. So I know I'm going to apply the chain rule. I can also see that the derivative of the inside will require the quotient rule, and so I'm ready to make that step by leaving myself some space on the right to do that extra work, and then being clear in my representation in my main section. All right, so let's go ahead and try a couple more where you're just going to be applying really the rules that we've already learned to take the derivative of some more advanced functions. All right, here are 4 for you to complete. Make sure that these are done, ready to present. Number 4 has 3 parts. All parts will be presented, so make sure that you're ready to go.